Today's lesson is on integrating functions using long division and completing the square. So just a couple more tools for your toolbox for integrals. All right, well, let's get started. First example is the integral of 4x squared minus 14x plus 9 all over x minus 3. So what we can do when we have this type of function, this is essentially just division of polynomials. So we can do long division. In this one, because we're dividing by a linear binomial, we can actually do synthetic division. So I'm going to do one example with synthetic division and then one with long division. So I'm going to just divide these polynomials. So synthetic division, because I'm dividing by this x minus 3, I'll put a positive 3 here. Coefficients, bring down the 4. Multiply and add. Multiply and add. So after dividing this, I'm essentially just like simplifying it down a little bit. It's now the integral of 4x minus 2 with a remainder of 3 over x minus 3. And now when it's in this form, we have the tools to integrate it. So the antiderivative of each term, so 4x will be 4x squared over 2 minus 2x. And okay, this last one, let's think. So 3 over x minus 3. That could be rewritten as 1 over x minus 3. So 1 over x, we're going to think natural log. If you do u substitution, say u equals x minus 3, kind of a shortcut, when you go to do the derivative here, if the derivative is 1, then the shortcut is really just like, let's just substitute that into the natural log. So this is going to be plus 3 natural log of absolute value of x minus 3 plus c. And there we have my antiderivative of this original function here. Okay, next example using polynomial division. 6x squared minus 7x plus 8 over 2x plus 5. So for this one, because this has a leading coefficient greater than 1, synthetic division just isn't really all that convenient. So we're going to do long division for this one. Okay, so 6x squared divided by 2x is 3x. And then multiply out in front, so I have 6x squared plus 15x, and then subtract. Negative 22x, bring down the plus 8, and then divide. Negative 22x divided by 2x, so minus 11, and then multiply out in front. So negative 22x minus 55, and then subtract again. These cancel, and then minus a negative, that goes up to 63. So now I'm taking the integral of 3x minus 11 with the remainder of 63 over 2x plus 5. So now if I find the antiderivative of each term, I'll have 3x squared over 2 minus 11x. And then off to the side, I'm going to think of this integral of, I'm going to bring 63 out, 1 over 2x plus 5. And then we're going to do u substitution for this term. Okay, so then the derivative of our u is just 2. So dx is du over 2. So then I have 63 and the integral of 1 over u du over 2. So then I'm going to bring this over here. So now I have, let's see, 63 over 2. And then 1 over u, there's going to be natural log of the absolute value of, plug u back in, 2x plus 5 plus c. And now the next two examples will follow the theme of completing the square. 4 over x squared minus 4x plus 5 dx. So we are going to complete the square of this numerator. So to do that, I'm going to group the first two terms together, x squared minus 4x, and the plus 5 will be on the outside. And then remember, completing the squares, when you do that, b over 2 squared. So in this case, negative 4 divided by 2 squared is positive 4. So I'm going to insert that in here. So I've just now completed the square here. But if I'm going to add 4, I have to balance it out. I'm adding 4 inside parentheses, so I will subtract 4 outside of parentheses. And now I will have 4 over, let's factor a perfect square trinomial. This factors down to x minus 2 squared, and then combine here, 5 minus 4 is 1. Okay, and if you don't see where we're going yet, what if I bring the 4 out in front, and I have 1 over x minus 2 squared plus 1. So 1 over x squared plus 1, hopefully that's making you think inverse tan. So if you do u substitution, so if we say that u is x minus 2, and then when you take the derivative, so if you just get 1, this is an easy one. So if you don't have like that leading coefficient, really we can just plug this into the inverse tan. So antiderivative of this would be 4 times the inverse tan of insert x minus 2 and then plus c. And there we have it. And now for our last example, another one where we will be completing the square. So this time 8 over the square root of negative 8 plus 6x minus x squared dx. So I am just going to, off to the side, rewrite this in standard form. Negative x squared plus 6x minus 8. And then if I group the first two terms together, I'm going to factor out so the leading coefficient is not negative. So negative x squared minus 6x minus 8. So now if I rewrite this, I'm going to write it as 8 over the square root of negative, and then in parentheses, x squared minus 6x. I'm going to give myself some space, minus 8. So to complete the square, take this middle term, negative 6 over 2 squared, that is 9. So if I add in plus 9, now technically adding in this plus 9 though, if I have this negative out in front, what I have added to the equation is actually a negative 9. So I will now, the opposite of this minus 9, it would be to add 9. So the integral of 8 over the square root of negative, now let's factor this. This will go down to x minus 3 squared, and simplify this plus 1. I'm going to rewrite this a little bit. 8 over the square root of, let's write it as 1 minus x minus 3 squared. So now, if you think about 1 over the square root of 1 minus x squared, you should be thinking about inverse sine.